Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is Space Time, Series 26, Episode 88, for broadcast on the 24th of July, 2023. Coming up on Space Time, astronomers discover a mysterious new type of stellar object hiding in plain sight. NASA's Mars Perseverance rover samples an ancient Martian riverbed. And the first Bepi-Colombo flyby of the planet Mercury shows electron rain triggering X-ray aurorae. All that and more coming up on Space Time.
Welcome to Space Time with Stuart Gary.
Astronomers have discovered a mysterious new type of stellar object, one which is challenging science's understanding of the physics of neutron stars and white dwarfs. A report in the journal Nature suggests this object could be an ultra-long period magnetar, a rare type of neutron star with extremely powerful magnetic fields, which can produce powerful bursts of energy. Problem is, the evidence for that isn't quite adding up. Until recently, all known magnetars released energy at intervals ranging from a few seconds to a couple of minutes. But this newly discovered object emits radio waves every 22 minutes, and that would make it the longest period magnetar ever detected. Put simply, it's rotating far too slowly to emit radio waves based on our current understanding of stellar physics. The object's been catalogued as GPMJ 1839-10. It's located 1,500 light-years away, so it's within our Milky Way galaxy, and it's in the direction of the constellation Scutum. Astronomers discovered this weird object using the Murchison Wide Field Array radio telescope in outback Western Australia. The study's lead author, Dr. Natasha Hurley-Walker from the Curtin University node of the International Centre for Radio Astronomy Research, says if this is a type of neutron star magnetar, then it challenges science's understanding of these objects, which are already some of the most extreme and exotic stars in the universe. And amazingly, it's not the first of these objects to have been discovered. An earlier version was discovered by Curtin University's Tarana Doherty. Initially, scientists couldn't explain what they were seeing, describing it simply as an enigmatic transient object that would intermittently appear and disappear, emitting powerful beams of energy 3 times an hour. So they started searching the skies using the Murchison Wide Field Array for similar objects in order to determine whether the first one was an isolated event or just the tip of the iceberg. And they soon found what they were looking for in the guise of GPMJ 1839-10. Interestingly, this new object emits bursts of energy lasting up to 5 minutes, which is 5 times longer than the first object. Other telescopes, including the CSIRO's Parkes Radio Telescope, the Australia Telescope Compact Array in Narrabri, and ASCAP, the Australia Square Kilometre Array Pathfinder Radio Telescope, were called into the search, as was South Africa's MEERKAP Array and the XMM Newton Space Telescope, all employed to learn more about this object's unique characteristics. Now, armed with GPMJ 1839-10 celestial coordinates and characteristics, the authors also began searching the archives of other telescopes, and Hurley-Walker says it showed up in observations by the Giant Meter Wave Radio Telescope in India and the National Science Foundation's Very Large Array in New Mexico, observations dating back as far as 1988. She says they failed to identify the object because no one had expected to find anything like it. So, are we talking about a magnetar or not? Well, the first thing to remember is not all magnetars produce radio waves, and this object exists below the so-called death line, a critical threshold where a star's magnetic field becomes too weak to generate high-energy emissions. Put simply, this newly identified object is spinning way too slowly to produce radio waves. It's below this death line. Now, assuming it's a magnetar, and that's still a big assumption at this stage, it shouldn't be possible for this object to produce radio waves. But that's exactly what the authors have been detecting. Every 22 minutes, it emits a 5-minute pulse of radio wavelength energy, and it's been doing that for at least 33 years. This discovery has important implications, not just for science's understanding of the physics of neutron stars, but also the behaviour of magnetic fields in extreme environments. It also raises new questions about the formation and evolution of magnetars and could shed light on the origins of that mysterious phenomenon known as fast radio bursts. Right now, Hurley Walker and colleagues plan to conduct further observations of the magnetar in order to learn more about its properties and behaviour. She says they also hope to discover more of these enigmatic objects in the future in order to determine whether they are indeed ultra-long period magnetars or something even stranger and more phenomenal.
So we've been searching the skies with the Murchison Wide Field Array, which is a radio telescope here in outback Western Australia. And we've found a strange repeating radio source. It produces pulses of radio waves that last for about 5 minutes each, and they repeat every 22 minutes. And this is a little bit like a pulsar, but slowed down by about a factor of 1,000. And that's extremely unusual. You mentioned magnetars just then. Well, magnetars are pulsars with very complicated magnetic fields. And we thought that perhaps a source like this could be a magnetar because the really strong magnetic fields might give it enough energy to produce the radio waves, even though it's spinning, as far as we can tell, too slowly to do so. The thing is, magnetars should also be bright in the X-ray, and also they should only produce radio waves for a few weeks or a few months. This source doesn't produce any X-rays that we can tell, and it's been active for over 30 years. It was in the data about 30 years ago, but nobody actually noticed until now. So the techniques that we've come up with in order to scan the skies using quite clever imaging techniques and good detection algorithms and powerful supercomputers to process all of that data, those are the techniques that have allowed us to find these signals. And then when we applied them to that same patch of sky in data from older telescopes that have been running for a long time, that's when we started to find that the source has been there the whole time. But what we were missing 30 years ago was the technique.
Tell me about the patch of sky it's in.
From our point of view, it's in the Scutum constellation, but in a kind of more zoomed out, astronomical, top-down perspective, it's in our own Milky Way galaxy. So our solar system is one of hundreds of billions of systems all through our galaxy. That's what our galaxy is. It's a whole collection of stars. And the source that we're looking at is kind of right towards the middle of the galaxy, a little bit to the west in terms of like galactic coordinates. We know it's about 15,000 light years away. For context, our whole galaxy is sort of 40 to 80,000 light years across. So it's kind of deep into the galaxy, really quite far away. So it's amazing how luminous it must be to be so detectable by our radio telescopes. Towards that part of the sky, you're sort of looking a little bit kind of left of the center of the galaxy. It actually is a bit of a challenge following it up in optical wavelengths. So, we made the detection in radio, and then we want to look with very powerful optical telescopes. But when you look towards that position, as they say in 2001, my God, Dave, it's full of stars. It's completely crowded. There's just so many objects along that line of sight because you're looking right through the thickest part of the galaxy. It makes it really challenging.
Is it a neighbourhood where we find lots of starburst action going on or lots of large stars with short lifespans that are likely to become neutron stars?
That's a great question, and not particularly. It's a little hard to tell because our distance estimate probably has an error bar of about 5,000 light years on it. So it's 15,000 light years away, plus or minus 5,000. It's actually quite difficult to tell how far away sources detected in the radio are, especially when they're completely new. So we have no idea whether it's bright and far away or dim and relatively close. What we use to find the distance is that we pick up radio waves across many different frequencies. And the interstellar gas in our galaxy, the electrons in our galaxy, they actually make the low-frequency waves appear just a little bit later, a few seconds later than the high-frequency radio waves. This is a well-known effect called dispersion. And if you roughly know how many electrons there are between you and another place in the galaxy, you can kind of work out the distance by seeing how slowed down those low frequencies are. So that's what we've used, but our knowledge of how many electrons there are is not certain enough to do more than it's about 15,000 light years away. We know it's not next door anyway.
It's a ballpark figure. So no one's seen anything like this before. This is something new to science.
Well, the reason we were searching was because we discovered a source that repeated every 18 minutes, and we published that last year also in Nature. But the thing is, with that source, it was only on for a few months. And that's a little bit easier to explain with that magnetar theory. Perhaps just for a brief time, you have a neutron star that gets its magnetic field all tangled and confused, and that produces enough extra energy to overcome this very slow rotation rate and still produce radio waves. And then that's a little bit more explicable if it's only on for a short time. But this source has been on for 30 years, so it looks a lot like a normal pulsar. But pulsars, like, we thought we understood them. And we thought that once they started rotating about once a minute, maybe once every 2 minutes, there was just absolutely no way they could produce radio waves. And yet we're seeing them, and we have been seeing them. So it's a real puzzle for the theorists. And that's, again, why the discovery has been published in Nature and why people are so excited about it.
What are the hypotheses going on about it? What are the sort of ideas you guys are coming up with as to what could be doing this?
Well, the magnetar theory still has legs, as it were. People are working on that. There's also the possibility that it's a white dwarf. So a neutron star is occurs when a star that's sort of more massive than our sun ends its life and collapses, and that there's so much mass there that it squashes everything into neutrons. The star that's about the mass of our own sun doesn't quite get there. It's not quite massive enough. So instead, it ends its life as a white dwarf, which is basically all of the atoms are crushed together, but the protons and electrons don't recombine to form neutrons. So you have a big ball of very hot atoms. It's about the size of the Earth, and it still has the mass of the sun in it. So it's a very big and massive and interesting object. The magnetic field, just like neutron stars, the magnetic fields get kind of concentrated. And so there's a theory that a white dwarf could also produce radio emission. The thing is, we only know of a couple of white dwarfs that do produce radio emission, literally two. Both of them are in very tight binaries, as in they have a companion star that they orbit around, or that orbits with them, every few hours. So they're very, very close to that star. And they themselves rotate every couple of minutes. So they're still rotating much faster than our objects. So it's a little bit puzzling. It's one of the theories. That's a little bit it, to be honest. I went to a big conference with basically experts in transient radio astronomy from all over the world. And I presented my work, and my collaborators presented their work, and everybody talked about all of the interesting objects that they found and all of the ways in which we think the radio emission is being generated. It was very exciting. And right at the end of the conference, I asked people to put up their hands. Do you think the long period radio transients are neutron stars, white dwarfs, or something else? And the whole room was completely split. There's about a third to each. So this is the world experts gathered in one place, having done nothing but talk about this and other radio phenomena for a week, and they weren't sure either. So I think it's going to take the whole community, and that's why I'm so excited that the paper is now out there so people can read it. And the best thing is, this source is still on. So people can come up with new ways of observing it, point their telescope, and then see what the data say, which I think is just fantastic.
Yeah, we want to see if we can see this and see what's in its neighbourhood if it's got a binary partner.
Yeah, that's right. And it's, as I say, it's in a crowded field. So I think you'd need something like JWST. I think we'd probably do it. Very hard to get time on. But now that the paper's out there, maybe a little bit easier. And that would be really exciting. The other thing is I'm still working on finding new examples of this kind of source. You know, clearly the design of the surveys that I've created and the techniques that I've used, they work. So now I just need to apply them to more data, and maybe I can find one that's in a less crowded field. And I think that would be a good way of trying to figure out what these things really are.
Now, as well as looking at it with the Murchison Wide Field Array, ASCAP was involved, so too Meerkat, XMM Newton played a part, Parkes of the Dish. What else was there? The Narrabri Radio Telescope Network.
Yep.
So you've looked at this with a lot, seeing it so many different ways. Is there anything at all that's coming up that's unusual in one particular waveband?
Yeah, I'm so glad you asked that, because it's one of the things that people don't often ask about, and I think it's one of the most interesting, but it's a little tiny bit technical. So, let's imagine you go to the beach and you've got some lovely polarized sunglasses, and you're looking out over the water and you get that tremendous glare off the water. But when you pop your polarized sunglasses on, all of that glare disappears. That's because the light waves that are coming from the sun and reflecting off the water waves and going into your eyes, the reflected ones are all at a particular angle, and your polarizers are designed to block that angle. But if you turn them to the side, then you get all of that glare coming through. So light can be polarized. Now, radio is just another form of light, and it can also be polarized. So when we made observations with Meerkat and indeed ASCAP, they are sensitive enough and they have really beautiful polarization measurements that allow us to look at the polarization of the source. And what we see is that, for the most part, the pulses are polarized in a single direction. But every so often, for just a few milliseconds, that polarization completely swaps by 90 degrees. It's as if you were standing on the beach, you were wearing your polarized sunglasses, and suddenly the whole ocean flashed a bright silver with the reflected sunlight just for a second. And you say, what is going on? And I think that's a clue to something about the magnetic field of the source. Now, we only have a few of these observations, and so I have applied for more in order to find out, more. How often do these things occur, and what can that tell us about the magnetic field that's generating the radio emission? So that's another really exciting line of research that we're working on. And I hope we can catch some bright pulses and figure this out.
That's Dr. Natasha Hurley-Walker from the Curtin University node of the International Centre for Radio Astronomy Research. And this is Space Time. Still to come, NASA's Mars Perseverance rover takes its first sample from an ancient Martian riverbed, and X-ray aurorae triggered by electron rains discovered on Mercury. All that and more still to come on Space Time.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money, a Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
NASA's Mars Perseverance rover has just collected its 20th core sample from the surface of the red planet. Mission managers are especially excited about this latest rock sample because it was drilled from an outcrop composed of tiny chunks of other rocks that were carried in river sediment from further upstream and eventually deposited on the floor of the river delta. Over billions of years, these sedimentary deposits became cemented together. The new sample, nicknamed Emerald Lake, was collected from a location called Otis Peak on the 832nd Sol or Mars day of the mission. Perseverance project scientist Ken Farley from Caltech says conglomerates like this pack a lot of information about places the rover may never visit, so each new rock fragment represents a new geologic story. He says, while the water that created the Martian riverbed that Perseverance is currently exploring evaporated billions of years ago, the story carried by those waters remains fresh, stored in the rocks. Perseverance is collecting these samples so that they can eventually be brought back to Earth by a joint NASA-European Space Agency Mars Sample Return mission. Once back home, they'll be studied by lab equipment too large and complex to bring to Mars. Scientists will be able to study each pebble and fragment in the core sample in order to determine details such as its age, what the environmental conditions were like in the river when the conglomerate was formed, and importantly, whether it contains any signs of ancient microbial life. Remember, the search for past life on the red planet is the primary objective of this mission. Now in its third science campaign, Perseverance is exploring the top of a fan-shaped river delta of sedimentary rock that stands about 40 metres above the Jezero crater floor. With the sample now safely sealed and stored in its cache, the rover is now on its way to a low ridge called Snowdrift Peak. But in order to get there, it'll need to cross a field of boulders. As with the rock fragments in the Otis Peak sample, scientists believe the boulders at Snowdrift Peak were likely formed elsewhere and then transported to their present location billions of years ago by the ancient river. Boulders are also desirable because of their large surface area that allows scientists to visually investigate many potential distinct rocks in a single image. Fairley says whether the boulders appear intriguing enough for closer examination and even possible sampling remains to be seen. Quite literally in this case. I guess you can say the science team are taking a page from the past. In days old, prospectors looking for gold or diamonds often looked into rivers and gullies in order to determine whether there might have been any deposits further upstream. After all, why bother hiking there when you can let the river do all the work? This is Space Time. Still to come, the first Bepi-Colombo flyby of the planet Mercury finds electron rain triggering X-ray aurora. And later in the science report, a new study warns that most of the world's population could be affected by polluted water by the year 2100. All that and more still to come on Space Time. The joint European Space Agency, Japanese Aerospace Exploration Agency Bepi-Colombo mission has discovered how electrons rain down on the surface of the planet Mercury to trigger high-energy X-ray aurorae. The mission, which has been travelling to the solar system's innermost planet since 2018, successfully carried out its first Mercury flyby back on the 1st of October 2021. The new findings, reported in the journal Nature Communications, are based on observations made by the spacecraft during that close encounter. Auroral activity on Earth is generated by interactions between the solar wind, a stream of charged particles flowing out from the Sun, and an electrically charged upper layer of the Earth's atmosphere called the ionosphere. As Mercury only has a very thin atmosphere called an exosphere, its auroras are generated by the solar wind interacting directly with the planet's surface. The Bepi-Colombo mission consists of 3 spacecraft joined together and operating as a single unit. There's ESA's Mercury Planetary Orbiter, JAXA's Mercury Magnetospheric Orbiter, and the cruise stage, which provides propulsion during the 7-year journey to Mercury orbit insertion. During its first Mercury flyby, Bepi-Colombo swooped to within 200 kilometres above the planet's surface. The observations by the plasma instruments aboard the Mercury Magnetospheric Orbiter enabled the first simultaneous observations of different kinds of charged particles from the solar wind in the vicinity of Mercury. The study's lead author, Sei Ozawa from JAXA's Institute of Space and Astronautical Science and the University of Pisa, says the flyby allowed scientists to witness for the first time how electrons are accelerated in Mercury's magnetosphere and precipitate down to the planet's surface. While Mercury's magnetosphere is much smaller than the Earth's and has a different structure and dynamics, the authors were still able to confirm that the mechanism that generates aurorae is the same throughout the solar system. During the flyby, Bepi-Colombo approached Mercury from the right side of the northern hemisphere and made its closest approach near the morning side of the southern hemisphere. It observed the magnetosphere on the daytime side of the southern hemisphere and then passed out of the magnetosphere back into the solar wind. Its instruments successfully observed the structure and boundaries of the magnetosphere, including the magnetopause and bow shock. The data also showed that Mercury's magnetosphere is in an unusually compressed state, most likely due to the high-pressure conditions in the solar wind. The acceleration of electrons appears to occur due to plasma processes on the dawn side of Mercury's magnetosphere. The high-energy electrons are transported from the tail region towards the planet, where they eventually rain down onto the planet's surface. Unimpeded by an atmosphere, they interact with material on the surface and cause X-rays to be emitted, resulting in an auroral glow. Although aurorae have been observed on Mercury previously by NASA's Messenger spacecraft, the processes triggering X-ray fluorescence on the surface had not been well understood or witnessed directly. This report from ESA TV.
Images from the NASA Messenger mission are the best we have of Mercury. NASA's Messenger mission did a great job, but BepiColombo consists of two orbiters using complementary orbits with more combined instruments. Plus, unlike Messenger, it will obtain high-resolution images of the entire planet. The planet is also shrinking in size, possibly due to cooling. Plus, there may be active volcanoes, so there is much more to learn.
Mercury is a very mysterious planet. Every time we went there, we found new surprising results. And that is the reason why we do BepiColombo. And we hope with BepiColombo, on one hand, we are able to answer many of these new questions. But I'm pretty sure we found a lot of new surprising results which raise new and other questions which we then need to follow up.
It has highlands and lowlands like other planets, but unlike Earth, Mercury rotates on an axis perpendicular to its orbit.
Due to the fact that Mercury is not tilted, there are some craters on the poles where the sun never shines into it. And inside these craters, Messenger found water ice. It was detected even earlier in the 80s from ground that there were rather bright spots and there were some hints that it might be water ice. But now from Messenger, we are pretty sure that we have water ice in craters. And that's pretty much surprising. Think about it. You have a planet on the surface 450 degrees, and then you have water ice at the poles. It's kind of unbelievable.
Fortunately, there's an instrument on board called MERTIS, which can measure the surface temperature directly to see if it's cold enough for water ice. Knowing the makeup of the planet's dark surface is also important. A team at DLR, the German space agency, have built a special chamber to heat up samples to examine how they behave at high temperatures. These can then be compared with what will be found on the planet. Planetary scientists are unsure how it formed. It could have originated beyond Mars, with an impact pushing it closer to the Sun. Or it could have formed at lower temperatures in its current position. If so, current theoretical models will need a rethink.
And one of the things why I like working on Mercury is we need to understand Mercury in order to understand how planets form. If we have a model that forms all planets but not Mercury, that model is basically useless because you need to get that one as well.
BepiColombo arrives at the planet in 2025. Then, for this joint mission from ESA and the Japanese space agency JAXA, it will be time to unlock Mercury's mysteries.
This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study warns that most of the world's population, up to 5.5 billion people, could be affected by polluted surface water by the turn of the century. The findings, reported in the journal Nature, are based on new computer modelling which shows that sub-Saharan Africa is predicted to become a global hotspot for surface water pollution by the year 2100. Researchers used a high-resolution global surface water quality computer model to simulate water temperature, indicators of salinity and organic and pathogen pollution for the period from 2005 through to 2100. They found that poor surface water quality could affect 5.5 billion people by 2100, and people living in developing countries would be disproportionately affected. A new study shows that new diagnoses of HIV, the human immunodeficiency virus that causes AIDS, have stabilised in Australia, with 555 new cases last year. The findings by the University of New South Wales Kirby Institute were released ahead of the 12th International AIDS Society Conference on HIV being held in Brisbane. The human immunodeficiency virus HIV is an infection that attacks the body's immune system, causing acquired immunodeficiency syndrome or AIDS. It's thought to have originated from infected primates and monkeys in Western Central Africa and was first identified in humans in May 1981 when a large cohort of otherwise healthy young biological males suddenly began dying from a range of unusually rare diseases. HIV targets the body's white blood cells, such as helper T cells, specifically CD4 plus T cells, as well as macrophages and dendritic cells, weakening and causing the progressive failure of the immune system. This allows a wide range of opportunistic diseases such as tuberculosis and several types of cancer to become critical, eventually killing the patient. HIV spread from person to person through body fluids, including blood, breast milk, semen, and vaginal fluids. Early symptoms include fever, fatigue, headaches, a skin rash, swollen lymph nodes, aching muscles, joint pain, nausea, vomiting, diarrhea, night sweats, a sore throat, and a dry cough. The only known treatments for HIV involve powerful drug cocktails known as antiretroviral therapy, or ART. The World Health Organization estimates that up to 52 million people have been killed by AIDS, with another 40 million currently living with HIV. An analysis of ancient human genomic data suggests that Copper Age farmers and steppe pastoralists may have interacted 1,000 years earlier than previously thought. Researchers analysed genetic data from 135 ancient individuals from 8 sites across southeastern Europe and the northwestern Black Sea region. They found that while there was genetic continuity between the Neolithic and Copper Age groups from around 6,500 years ago, groups from the northwestern Black Sea region carried varying amounts of ancestry from Copper Age and steppe zone populations. The findings, reported in the journal Nature, suggest that the groups had cultural contact and mixed nearly 1,000 years earlier than previously thought, and that the transfer of technology between farmers and traditional hunters from different geographical areas was important for the rise, formation and expansion of pastoral groups around 5,300 years ago. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Spacetime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @Spacetime with Stuart Gary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary. And Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.